Alright, so in this video, I'm going to be talking about SemantiCache. Now, SemantiCache is basically a library that helps to supercharge your LLM applications. Now, how do I mean? So think about maybe you have a locally hosted model, or you have a model you're working through with like an API, and it's going to come with like some costs. And for each time you ask a question, it costs you to get responses because of the number of tokens that have been generated and stuff. But what if you could cache those responses, right? So if you're asking the same or similar questions, so semantically similar questions, SemantiCache, right? So for semantically similar questions, it will just pull up responses that have been saved to memory, and then you easily save on time. And the real advantage of this library is that you can achieve this in like very few lines of code. So here is the page for the package.
All right, welcome to Data Code. We'll talk about
AI, machine learning, data science, AI, data engineering, signal processing. Is that an orange? Computer vision.
deep learning,
AI, NLP, AI.
It's available on pip, so you could just pip install it. And the goal of the package is to make it very easy to implement caching, semantic caching for your LLM application. So it's platform agnostic, really. So whether you're hosting it locally or you're using like an API for a cloud hosted language model, it doesn't matter. It's just a few lines of code that are independent of the LLM itself. So it's really easy to use. So you can see here, cache.set is how you set a new record. Cache.get is how you pull a record, and you could clear the cache, or you could even, if you start clear files to true, it resets the entire cache, right? So you start afresh. And then the cool thing is that it also has like a leaderboard feature where you can easily track, which queries are like the most useful. So in case you're using a purpose-built system, maybe like a RAG LLM, and you want to know, okay, what kind of questions are people asking the most? With SemantiCache, you also get insight into that information, right? So it's really cool like that. So here's an example use case. I'm going to demo with like an experimental LLM app I built the other time, sometime last year, just for fun, right? So I'm just going to add that in. So you can see the documentation here. Okay, so here are the public methods, like I said, get, set, clear, and then to read the leaderboard, and then behind the scenes stuff. And then just to put it out there, I didn't like build this from scratch. It was built off of FAISS, that's Facebook AI Similarity Search, and the LangChain community libraries. But those two libraries might not be really straightforward to just jump into, and so I basically did that legwork of figuring out the logic of how the setting, retrieval, and all that's going to be, so you just have an easier way to go about it. And you can also customize how the cache works. So you can set it based on a specific number of records you want it to hold per time, or you can set it based on time to live, just like a normal cache system would work, right? And then because it's using a vector index to kind of like compare those queries to see which ones are most similar, you can also set the threshold for similarity as per what would define what semantically similar queries would be like. So the higher the value, the more distance there can be, right? So think about it as like the bandwidth. So 0.1 means it's like really tightly knit. So it's like only really close queries would bring the same response. But if you make it something high, like maybe 0.9, then vaguely similar questions would bring the same response, that type of thing. So here's what it looks like, right? Very simple, very easy. So I think I'm just going to jump into the demo right now. So clear this. I was just playing with it earlier before this video, right? So let me just start the app. So this is like the default setting for the app. Let me see, come back here. Okay, reload. Yeah, I'm able to connect. So I want to start the app from scratch. Okay, and it's up. So I'm just going to ask a random question. Tell me a long story about Abraham Aldo. So this is based off of like writings I've done because I have like a blog with like personal stuff really. So tell me a long story about Abraham Aldo, and then you see how long it takes to do that. Just to mention, I'm using Olama, so I'm using Llama 3.1, locally hosted with Olama, and it's GPU optimized also. So this is like I'm using like an RTX 3060 with 6 gigabytes of VRAM. So and it's taking about 21 seconds here to generate this response. The thing is, even if I clear the chat history and I ask the same question again, you see to take the same time. So it's like going through the same process again and again. Okay, so I guess I'll probably just pause and then show you what it looks like after waiting for a little bit for the response. Okay, so now see it's a bit faster, but still it's taking a lot of time, right? So we'll come here and just install the package and see how we can optimize with a semantic cache. So pip install okay. Right. Now, because I've had to work with some of these libraries already, like generally when you're working with an LLM application like this, you probably have some of these dependencies already installed, right? So you can see it just passed through a whole lot of them because most of, I mean, you probably already be using like LangChain. I think whilst that is going on, since I kind of already know the syntax, I'll just do what needs to be done. So from SemantiCache, import SemantiCache. Oh no, not semantic. Yeah, thank you, AI. I don't need that part. Okay, so then I can define an instance of the cache here. So cache because SemantiCache, and I'll just leave it with the default settings. Okay. Now, okay, so it's installed and or still installing, but almost there. So what I can then do is for this section of the code where it's actually doing an LLM response, I can just do something like this and say cache.get user question, and then I'll just use a conditional here because it returns none, right, if nothing is found. So I'll just say cache response equals to cache.get user question. I could just come here and say if cached response is not none, just return that, right, and go on with the rest of the application. Else response is equal to user input. You see, it's even smart. The code assistant, whatever, is smart. It's already picking it up. So if it's not in a cache, we want to take the user question and the response and set it to the cache, right? And then here I'm just going to add something else. Okay, yeah. So I want it to just signify if it gets the response from cache. So also st dot success response pulled from cache. Okay, so let's try this out. So basically what's happening here is when you ask a question, it'll first check from the cache if that question has been asked before. If not, right, then it gets the question through the regular route and then adds that question to the cache, right? Simple stuff. All right, so now let's go back to the front end and rerun. So now let me ask the same question. Tell me a long story. Okay, response generated in 21 seconds. Now let's ask the same question. I could just ask the same question again. And this time it should come up real quick. It should come up real quick. Okay, response pulled from cache, local variable response. Okay, so that's a different issue, but you can see how fast the answer came through. So let me see. Okay, I see what's going on now. So I could, if cache response is not none, I could just do something easier here, right? To just say response equals cache the response so that the rest of the code doesn't break, and then we just move on with our lives. All right, so I come back here, rerun, and now here's the cool part, and I'm going to demo it now. And the cool part about this. All right, so Control V, same question. All right, boom, 2.78 seconds from 20 seconds. Super cool. And now, so I'm going to just tweak the question a bit. So tell me a long story about Ibrahim Aldu. So can I say I want a long story about Ibrahim Aldu? Let's see. Or give me, let me see. Give me a long story about Ibrahim Aldu. And we want to see that in another, boom. So you see, it's like similar stuff, same timing, boom, fast. And now the cool thing is, you know, we didn't provision anything, so it by itself it generates local files for everything. It generates, just from the way you call the function, it generates a config file that you can then edit, right? And so here is your leaderboard. So I've asked that question like 3 times. So as people keep asking questions, they keep getting added to the leaderboard. And then this is like the actual memory, the index thing going on there. So I could use a different strategy and use time to live. And if I set maybe the time to live to like 5 seconds, which is really short, and then I set trim by size to false, then it means it will only save those responses in memory for 5 seconds. I'm going to try something here. Okay, so this took 10 seconds. Who is Ibrahim Aldu? Let's ask the same question again. And now that's been more than 3 seconds just right now. So let's see what happens. Yep. Okay. So I guess it's working now, because now if I paste that initial question, tell me a long story. Yeah. So now it's loading from scratch. So it's just basically because of the way the front end setup works. Like you literally have to kill it and then it comes back, right? So now it's generated in 14 seconds. Now it's taking as much time as it's supposed to. So you see, you can actually play with the settings and it will give you exactly what you want. You can customize it to behave in the way that you would want. So I'll just set it back to trim by size to true, so that would restore the former behavior, right? Okay, so that's basically it. I'll just show you the repository now. So this is what it looks like: SemantiCache, vector-based caching, query similarity search, automatic cache management. So it helps you to trim and all that, and it's persistent, as I've shown you. The files are there, so even when you restart the app, when you change the settings, you have to restart the server for it to, reinstantiate the class, because I'm just calling the class, right? So if it's actively running and you change the config file, you have to restart the app for it to work. So that's one thing you've taken from this demo. And then, as I've shown, these are the parameters you can change, and then you can change even the logging level in case you don't want your console to be flooded with a lot of logs. You can just switch it up to something higher, like maybe warning or critical, so it doesn't just log random stuff to you for you. And then yeah, so some of the improvements that can still be made, obviously, make more unit tests. It's 75% coverage right now, and then maybe less dependence on other libraries. So maybe a custom algorithm for the vectorization of the queries and stuff, or integration with other vector index engines, a more optimized logic for just the code in general. So I mean, it's open source, so you can just jump right in. If you see something that needs improving, I mean, create a new issue, hack right at it, we'll look at it together and we'll improve it. So my hope, my dream for this is that it really helps developers who are working on LLM stuff to just be able to quickly build, so you don't have to think too much about these things. And you've seen how it basically improves the response time. I mean, going from 20 seconds to 2 seconds, it's like boom. And then if you think about it from the cost perspective, if you're running these workloads on cloud, but it may be like a GPU enabled server, it's going to be compute heavy, so you don't want it having too much load. So if people are asking similar questions, you want those answers to be coming out real quick. So that has been it. If you enjoyed this video and you'd love to see more content, about LLMs, AI, machine learning, deep learning, stuff like that, like this video, subscribe, follow on all platforms, and let's keep going on this journey. Thank you for watching. See you on the next one.